Okay, so given all these issues that I've talked about in terms of problems that social psychology and other fields have run into, and those ideas from people like Ioannidis who have said that a lot of published research findings are false, what sorts of things that individual researchers are doing are contributing to this? So, I mean, we know that small sample sizes matter. We know that the incentive structures matter. We know that if you have a vested interest because of money or prestige or something, it matters. We know that hot areas matter. We know that people aren't replicating enough. But what in terms of like individual studies do we think might be inflating the false positive rate and leading to a lot of studies that are false? Because if we were only concerned about 5% of studies being false, this wouldn't really be that big of a deal, right? I mean, that's kind of the assumption of these types of tests that we do, these frequentist statistics using p-values and saying, we want a p-value that's less than 0.05 because we are willing to tolerate a 5% chance that our study results are not reliable or not actually representative of an effect. And that's what we're willing to tolerate generally. But way more than 5% of published research findings are wrong. And that's just a reality that is kind of hard to face and frustrating, but it's very true. That when we actually run replication projects, we find that maybe only sometimes as few as 40% of findings are actually replicating at a reasonable rate. So what sorts of individual level things are people doing that are contributing to these sorts of problems? One paper around the time that these three events that I talked about earlier were happening was more or less a survey. There were some other parts of this paper too, but they surveyed researchers in psychology to estimate how much people are doing these things. So I want to talk about what some of them are and look at the rates of how often people are admitting they're doing them or saying other people are. So this graph admittedly is a little bit busy. Excuse me. But on the x-axis, the horizontal axis, you have a lot of these different things that these researchers identified as questionable research practices. These are, I'm not going to say an exhaustive list, but it's some good things to note. I'm just going to go through them quick. Failing to report all dependent measures. So this is getting to something that I mentioned earlier about, if you use the same study in two different papers, it better be about, different variables or different relationships. Well, one important thing about that is you need to be upfront even in that first study and say, hey, we measured X, Y, and Z variables to test our hypothesis, but we also measured A, B, C, D, E, F, G, and H, for other purposes, or we measured these hoping they would work and they didn't. You need to be transparent about all those different things that you measure. And frequently people are not. So here, failing to report all dependent measures, what they most likely are trying to say is, somebody measured stress, let's say, and they measured it with behavioral indicators and self-report indicators and physiological indicators. But when they ran their analyses, only one of them worked, so they just didn't report the other two. That's a problem because that inflates the false positive rate, right? If they're only finding that one of those three things works, then they're only replicating themselves at a 33% rate, right? To put it kind of crudely. So you need to report everything so people can have confidence and transparency about what you've actually done. So collecting more data after you see if the results are significant. So let's say you don't have a decision rule about when you're going to stop collecting data. You collect 80 participants and your p-value is 0.06. So you're almost there to your p-value, right? So you just collect another 20 people just to see if it gets there. That is collecting more data after you know. Failing to report all conditions, kind of analogous to not reporting all dependent measures. You manipulate something in 2 different ways, and only one of the ways works, so you don't report it, basically. Kind of the opposite of this one over here is stop collecting data after you get your result. So you've collected 80 participants, you didn't really have a decision rule, you look and you see that you have a p-value of 0.03, so it's significant. Okay, I'm going to stop collecting data. Obviously, you should not be doing that either. You should have a sample size that you're shooting for that you don't change, and you don't look at your data before you hit that sample size, and you don't collect more afterwards. Rounding down p-values, so like if your p-value is p equals 0.051, that's over 0.05, but it is very tempting, obviously, to say like, oh, it's so close, I'm just going to say it's 0.05. Selectively reporting studies that worked. This gets to a much bigger issue that we refer to as a file drawer problem that I've mentioned in class a couple times before. The file drawer problem, or this is related, I guess, to the file drawer problem, that you do lots of studies that don't work out as a researcher. So everyone's file drawers, metaphorically, are full of all these null results or findings that didn't support their hypothesis. Because of this, we probably massively overestimate effect sizes because we're never reporting these non-existent or non-confirmatory tests of these effects. So only publishing studies that supported your hypothesis is another questionable research practice. Excluding data after looking at the impact of doing so, you should just have rules that you're going to exclude a certain proportion of outliers, or that you're going to exclude people that fail on attention check. So instead of like, you do that and see that it helps your effect size or it puts your p-value below 0.05. Oh, so then you do it. No, you should just have a rule about how you do it, and you shouldn't let that influence your findings. Claiming to have predicted an unexpected finding. This is another related thing that people call cute acronym, hypothesizing after results are known, HARKing. So if you find something really counterintuitive and interesting, and you just like make up a hypothesis later on to say like that you predicted it, that's obviously problematic because that inflates the false positive rate too, because you might just be capitalizing on chance by observing that. Falsely claiming results are unaffected by demographics. So people might say like, we controlled for gender and age and it didn't matter, or we looked at this between men and women and the results were the same. Maybe that's true, maybe it's not. Maybe people don't even check sometimes. Or falsifying data. This is one that is probably relatively rare, but it does happen, and I think it's pretty self-evident. So this chart is kind of complicated in the sense that it has these different rates. The dark and the white ones were questions that they asked people: how often do you do these, do you do these things? And what percentage of people do you think do these things? And then, because these researchers were probably rightly very cynical and thinking that people don't necessarily tell the truth about these things because they reflect poorly on them, even when the surveys are anonymous, they made an estimate from these admission rates to inflate them based to they used these two numbers to estimate what the actual estimate should be. So you'll notice those bars are uniformly higher because they're seeing here, for example, that around 68% of people are admitting that they don't report all the dependent measures, and they say, well, maybe 60% of people do that. But these researchers are saying it's probably actually more like 100% of people that are failing to report dependent measures, and so on. So these things are all, even no matter which estimate you look at, these things are all problems. And any one of these things could inflate the rate of false positives that we see in the research literature. But when all of these things are probably happening at once in certain papers, or in lots of papers, then we are definitely seeing an inflation of these false positives. So that whole Ioannidis idea of most published research findings being false, it's a scary idea that seems hyperbolic, but it might be very literally true, that most of these findings might actually be false. Another one that I think is really telling when you are looking at how often you think people are making these types of mistakes and engaging in questionable research practices, whether intentionally or unintentionally. They had people estimate how often people are doing these things, never once or twice, occasionally or often, and they had them rate a bunch of different things, like, are you doing it? Are your collaborators doing it? Are grad students doing it? Are people at other schools or institutions doing it? In your institution or people at other institutions. So you can see how biased these estimates really are, right? That when you're talking about yourself or your collaborators, that are basically the same here, people say, I never do this and my collaborators never do this, but I think grad students do it sometimes, and people at other institutions do it occasionally, and even people in my institution might be doing it once or twice or occasionally. So this is, if anything, an indication that people are very probably self-serving in the way that they are perceiving these things, and maybe denying to themselves that they are doing some of these questionable research practices and contributing to this high false positive rate. So a very social, psychological, meta-scientific thing to do a study about our perceptions of these problems. But it's really telling that people are kind of insulated by this self-serving bias around these sorts of issues. So, this is one thing to show that these things are likely, and show that we have biased perceptions of how likely they are, according to how close we are to them. But do these things actually contribute to problems in the literature? Do questionable research practices actually matter? So Simmons, Nelson, and Simonson are researchers that do a lot of work still, are very respected in this area, that tell us a lot about the best practices in science. Simmons, I had a chance to see him talk in New Orleans actually a few months ago, and he is like the driest person in the world when he's telling you all these horrible things about people's research practices and what it says about science, but in a way that's very inspiring and telling. I don't know or haven't met or seen Nelson, and Simonson. Yuri Simonson is a person that runs a Facebook group called Psychological Methods in Discussion. And he is just like a shit stirrer person that, is always saying that things are as terrible as possible, but is always contrarian too. So I don't know, I tend to think that things are maybe not quite as dire as he says necessarily, because I think part of what he tries to do is just always say that things in the state of science are as bad as possible. But anyway, 10 years ago, these people did something really interesting that opened a lot of people's eyes in light of those other events I was talking about, where they were conducting studies showing that listening to certain songs can change people's perceptions of their age and actually even change their ages. So in the first study that they ran, they wanted to show that contrasting your age with musical style can change your perceptions of your age. So they had 30 undergrads listen to either a control song, it was Windows control music, Windows operating system, I mean, or a kid's song, Hot Potato by the Wiggles. And they had people listen to the song and indicate how young they felt afterwards, very young to very old. And they, controlled for the participant's age by asking about their father's age. So what they found is that People felt older when they listened to Hot Potato, these musical contrasts. So listen to a young song, you feel old. People felt older significantly more when compared to when they listened to Control Song. P-value below 0.05 there. Another one that they did was musical contrast, and not just feeling younger, but actually getting younger. So they had 20 undergrads listen to either Control Song or When I'm 64 by the Beatles. Presumably listening to a song about being old makes you feel young. Then they indicated their birth date and their father's age, and they found that people were a year and a half younger if they listened to When I'm 64 compared to a Control Song. Their p-value less than 0.05 here, showing that if you play this song for people, it seems in this sample that people were getting younger. Obviously, they were doing this to prove a point. That's not possible. It didn't happen. But their data, just like we might say in a study that we would run, you assign people to this condition, you recorded a dependent variable, and you ran a test, and this is what you found. This is impossible. So if it's easy for them to find impossible things, then the way that we design studies obviously really matter. They actually did really run these studies. These weren't made up. They ran them. They used normal statistical approaches. They reported the actual results, but they engaged in a lot of these questionable research practices intentionally while they were running it. They just made these dishonest types of decisions until their results worked. So what I'm showing you here is the stuff that they reported that I talked about already is bolded. The stuff that's not bolded for study 2 is stuff that they left out. So they didn't report a condition. They played the wiggle song in study 2 too. They conducted their analysis after every 10 participants and just stopped when they had a significant result. They recorded all these other covariate measures and just didn't report all these other things that they tried and used to control for. When they didn't control for this silly father's age thing, then the finding was not significant. It was much smaller. So, and they they collected data from 34 participants and only reported it from 20 rather than using their entire sample. So this seems like cartoonish almost. It's so transparently silly that anyone would believe these things happening. But if you just make these somewhat normal decisions about how to report your results, you can lie with them. And people, that aren't even necessarily trying to mislead anyone might have been making these types of decisions and coming up with very misleading results and contributing to the false positive rate and the misleading nature of some of the findings in psychology. They also, after doing this, ran a computer simulation where they were estimating how likely it is to find a significant result by doing some of these things, engaging in some of these questionable research practices. So if you have 2 dependent variables instead of 1 that are related at a medium degree, but you just use 2 and you just report your results if one of them is significant, or if you just add 10 more observations all the time, or if you control for something that doesn't really matter, like controlling for gender if your study is about race, you don't really need to do that necessarily, or dropping a condition if you didn't find something. So they're estimating how likely it is to find a significant finding at these different alphas at 0.5, our usual one in the middle, if you did any of these things separately. So if you do any of these things, then you just like when I talk about inferential statistics, it's like rolling the dice twice, basically, is the first one here. And these other things are other things that can contribute to the false positive rate. So any of these things almost or more than doubles the chance that you're going to find a significant result. And if you do more than one of them, like if you did A and B, you added more observations and you used 2 dependent variables, then you have almost a 15% chance of finding that result. And so on. If you do all of these things, A, B, C, and D, then your test, it's easy. You're almost 2/3 of the time you're going to find a significant result, even though your alpha is at 0.05. So we would like to see this whole column be 0.05, right? But it's not true. So anytime these decisions enter into people's realm of possibility, we might be making these false types of conclusions and misleading each other, really, with the conclusions that we have in our papers. Part of their conclusion, the Simmons, Nelson, Simonson's paper, I want to put it up here for you. It's in the slides. I want to read it in its entirety because I think it puts this stuff better than I would be able to. Drink of water first. Okay, our goal as scientists is not to publish as many articles as we can, but to discover and disseminate truth. Many of us, and this includes the 3 authors of this article, often lose sight of this goal, yielding to the pressure to do whatever is justifiable to compile a set of studies that we can publish. This is not driven by a willingness to deceive, but by the self-serving interpretation of ambiguity, which enables us to convince ourselves that whichever decisions produce the most publishable outcome must also have been the most appropriate. This article advocates a set of disclosure requirements that imposes minimal costs on authors, readers, and reviewers. These solutions will not rid researchers of publication pressures, but they will limit what authors are able to justify as acceptable to others and to themselves. We should embrace these disclosure requirements as if the credibility of our profession depended on them, because it does. I think this is, again, really powerful, really important. And when we go on to the next presentation, I will talk about some of these disclosures and some of the other things we can do.